Welcome to the Android Interview Series 2024, Part 1. In this video, we'll explore the essential Android basics that every developer should master for interview success. Whether you're prepping for your first Android interview or brushing up after years in the field, this guide will help you navigate the core concepts and frequently asked questions. We'll cover everything from application architecture to UI components, lifecycle management, and more. Let's dive into the fundamentals that form the backbone of Android app development and set the stage for your interview journey. This interview series is structured to guide you through Android basics, expert concepts, Java and Kotlin fundamentals, coroutines, flows, Jetpack Compose, and Android architecture. Today, we focus on Part 1, Android basics. Understanding these basics is crucial before moving on to advanced topics. The series is designed to build your knowledge step by step, ensuring you're prepared for both technical and practical interview questions. Let's start by understanding the Android application architecture, which is the foundation for all Android apps. Android application architecture consists of several key components: content providers, services, intents, resource externalization, and notification. Content providers enable data sharing between apps, services handle background tasks, intents facilitate activity communication and data passing, resource externalization manages strings and graphics, and notifications alert users with lights, sounds, icons, dialogs, or toast messages. Understanding these components is vital for building robust Android applications and answering interview questions confidently. Application class is the base class in Android apps. It contains all other components, such as activities and services, and is instantiated before any other class when the app process is created. This class is essential for managing global application state and resources. Interviewers often ask about its role and lifecycle, so be prepared to explain how it acts as the entry point for your app and why it's important for initializing resources shared across activities and services. Context in Android is a handle to the system, providing access to resources, databases, and preferences. There are two main types: application context and activity context. Application context is tied to the app's lifecycle and is used when passing context beyond the scope of an activity. Activity context is tied to the activity's lifecycle and is used within the activity scope. Knowing when to use each context is crucial for resource management and avoiding memory leaks. Android applications are built around four main components: activities, services, broadcast receivers, and content providers. Each serves a distinct purpose. Activities manage the UI, services handle background tasks, broadcast receivers respond to system-wide events, and content providers manage data sharing. Understanding these components and their interactions is fundamental for both development and interviews. Services in Android perform long-running operations in the background without a user interface. There are three types: foreground service, background service, and bound service. Foreground services are visible through persistent notifications. Background services run without user interaction, and bound services allow components to bind and communicate directly. Services are ideal for tasks like data processing, file downloading, or music playback. The service lifecycle includes several key methods: onCreate, onStartCommand, onBind, onUnbind, and onDestroy. OnCreate initializes resources. OnStartCommand performs main tasks. OnBind enables communication. OnUnbind handles client disconnects, and onDestroy releases resources. Managing these methods properly ensures efficient resource usage and prevents memory leaks. A service runs on the main thread and can handle multiple tasks, requiring manual threading. Intent service creates a worker thread to handle intents sequentially, making it ideal for short, discrete background tasks. Service is best for long-running tasks needing interaction, while intent service is suited for tasks like file downloads or data syncing. A bound service allows components like activities or fragments to bind and interact directly. It provides a client-server interface and remains active only while clients are bound. Bound services are ideal for real-time data syncing, media playback, or location updates, where continuous interaction is needed. Intent service handles immediate tasks in the background, but doesn't survive app termination. Job Intent service, introduced in Android support library, uses Job Scheduler to persist tasks across app restarts or device reboots. Job Intent service is ideal for tasks needing guaranteed execution, like uploading logs or syncing data. An activity represents a single screen with a user interface and acts as the entry point for app interaction. Each activity is associated with a layout file defining UI components. Activities are central to user experience and are often the focus of interview questions about UI and lifecycle management. The activity lifecycle includes onCreate, onStart, onResume, on pause, on stop, on destroy, and on restart. On create initializes views on start, makes the activity visible on resume, starts user interaction on pause, handles backgrounding on stop, hides the activity on destroy, finishes it, and on restart, prepares for reactivation. Understanding these methods is key for managing UI and resources. On create is called once during the activity lifecycle, either at app start or after destruction and recreation. On start is called whenever the activity becomes visible, typically after on create or on restart. Knowing the difference helps optimize initialization and resource management. If finish is called in the onCreate method of an activity, the system will invoke onDestroy directly without calling onPause or onStop. This scenario is rare but important to understand for interview questions about lifecycle edge cases. setContentView is set in onCreate because it's called only once, making it efficient for initializing the UI. Setting it in onResume or onStart is inefficient, as those methods are called multiple times, and setContentView is a heavy operation. onSaveInstanceState stores data before pausing the activity, while onRestoreInstanceState recovers the saved state when the activity is recreated. Both receive the same bundle, but you must check for null to distinguish between new and restored instances. Android supports 4 launch modes: Standard, Single Top, Single Task, and Single Instance. Standard creates new instances, Single Top reuses the top instance, Single Task creates a new task and root instant, and Single Instance launches activities in separate tasks. Understanding launch modes is crucial for managing activity stacks and navigation. When the user rotates the screen, the current activity instance is destroyed, and a new instance is created in the new orientation. On restart is invoked first, followed by other lifecycle methods. Handling screen rotation properly ensures data persistence and UI consistency. 2 ways to clear the back stack when launching a new activity: using flag activity clear top or combining flag activity clear task with flag activity new task. These flags help manage navigation and ensure the correct activity stack for user experience. Removes all activities above the target activity, making it the root. If no instance exists, a new one is created. Flag activity clear task clears all activities, making the launched activity the new root. Use flag activity new task with clear task for best results. Activities are containers for the user interface, while services perform background operations without a UI. Understanding the distinction is key for interview questions about app architecture and component responsibilities. On trim memory informs an app about its current memory status, allowing resource management and memory release. It's called with different urgency levels, helping apps optimize performance and avoid being killed due to low memory. Job scheduler schedules background tasks under specific conditions, like network availability or device charging. Introduced in Android 5, it defers jobs until optimal conditions are met, improving device efficiency and battery life by batching tasks. Content providers manage access to structured data and enable sharing between applications. They define data security and connect data in one process with code running in another. Access is managed via Content Resolver, which handles queries and returns results. To access data, ensure your app has read permissions, obtain Content Resolver via context, and use Content Resolver query to retrieve data. The query returns a cursor, allowing you to extract data from columns. This process is essential for secure and efficient data access. Broadcast receivers respond to system-wide events, such as network changes or low battery. They can be registered in code or manifest, and are useful for tasks like reacting to connectivity changes in messaging apps. Understanding their role is vital for event-driven development. Intents are messages used to pass information between Android components. Explicit intents call activities within the same app, while implicit intents invoke system actions like sending emails or SMS. Mastering intents is key for component communication. Sticky intent remains in the system after broadcast, allowing future receivers to access the data even if they register after the broadcast. While useful for delayed access, sticky broadcasts are discouraged in modern Android development. Alternatives like View Model and Live Data are recommended for secure, efficient data sharing. A pending intent grants another app or system component permission to execute a predefined action on behalf of your app at a later time. It's commonly used in notifications, alarms, and location updates, enabling actions to be triggered under specific conditions. An action represents a specific operation an intent can perform, defined by a string constant. Actions are fundamental for specifying and handling operations, allowing Android components to respond to events or tasks. Examples include launching activities or sending broadcasts. Intent filters define the types of intents a component can respond to, specified in Android manifest, XML or programmatically. They enable apps to interact and respond to system-wide events, making component communication flexible and dynamic. A fragment is a UI entity attached to an activity, allowing reuse across different activities. Activities provide screens for user interaction, while fragments represent portions of UI or behavior. Fragments depend on their host activity for lifecycle and input events. The fragment lifecycle includes onAttach, onCreate, onCreateView, onActivityCreated, onStart, onResume, onPause, onStop, onDestroyView, and onDestroy. Each method manages initialization, UI creation, visibility, activity interaction, and cleanup. Understanding fragment lifecycle is crucial for UI consistency and resource management. Activities provide screens for user interaction, while fragments represent behaviors or portions of UI within an activity. Fragments have their own lifecycle and input events, and can be added or removed as needed. This relationship enables modular UI design and flexible app architecture. Replacing a fragment removes the existing one and adds a new fragment, invoking lifecycle events like onCreateView. Adding a fragment retains existing fragments, stacking new ones on top. Understanding these differences helps manage fragment backstack and lifecycle events. Retained fragments survive configuration changes, like screen rotations, by setting setRetaininstance true in onCreate. This preserves data and state, preventing fragment destruction and recreation. Retained fragments are useful for maintaining long-lived data across lifecycle changes. Back navigation in fragments can be handled using onBackPress dispatcher to listen for backpress events and navigate accordingly. Proper back navigation ensures smooth user experience and prevents unexpected fragment behavior. Fragments can communicate using a shared view model, direct interface callbacks, fragment result API, or passing data through arguments. Shared view model is the most modern approach, ensuring data consistency and seamless sharing within a single activity. OnCreateView is called when the fragment creates its view hierarchy, used for inflating the layout. OnViewCreated is called after onCreateView, ideal for initializing UI components and setting up listeners. Knowing the difference helps organize UI setup efficiently. To update the UI of an activity from a background service, use Broadcast Receiver, Shared View Model with Live Data, Messenger, or Local Broadcast Manager. These methods enable secure and efficient communication between services and activities, ensuring UI updates reflect background changes. RecyclerView. Adapter bridges the data source and RecyclerView UI, creating view holder objects and binding data efficiently. It recycles views to improve performance and manages data changes, promoting modular and dynamic list implementation. Constraint Layout enables large, complex layouts with a flat hierarchy, improving performance and flexibility. It allows responsive UIs that adapt to different screen sizes and orientations, making it easier to design dynamic interfaces in Android Studio. Linear layout arranges elements vertically or horizontally in a row or column, while relative layout arranges elements relative to the parent or other elements. Choosing the right layout is essential for efficient UI design and interview questions about layout management. Frame layout is designed to contain a single item, making it efficient for displaying one view. When multiple views are added, they stack on top of each other, useful for overlays or HUD elements. Understanding frame layout helps answer questions about UI layering and design.